Kia ora. I'm just going to do a walkthrough from page 67 onward from the book. Okay, pumpkins from a large crop are found to have a mean weight of 4.1 kg. Boom. As soon as I see mean, what I'm going to do is draw a line bang in the middle of my distribution, normal distribution, after I've probably drawn it. And then I'm just going to write here that the mean equals 4.1. Right, first thing I do. With a standard deviation of 0.45, I kind of like putting this down here as well, but you don't really need to. You could just like highlight it or something. Calculate the probability that a pumpkin weighs between 4.1 kg and 5 kg. Between here and here. Okay, so where is 4.1 kg? This one's really convenient because it happens to be right in the center, so it's from the middle over to 5 kg, so 5 kg is going to be to the right. Now you can sort of work out by logic how much of a proportion is going to be filled in by looking at the standard deviation. So this is in fact exactly 2 standard deviations away, because 2 times 0.45 is 0.9, and so I'm going to fill in, I'm going to go about 2/3 of the way along my distribution. You don't need to be too anal about this, but yeah, it's just something to do so you get a good idea of what the probability is going to be around about. So now that I know that the probability is going to be around about like 40% or something like that, right? So then I can sort of check my answers as I go. Okay, is that everything I need? Nearly. Okay, I actually don't follow their steps. I'm going to do a different style and it will be more helpful eventually. What I do is I draw a whole nother distribution, and I draw it exactly the same size. Oh man, that's ugly as heck. Oh, I draw it the same, and the reason I do that is because this is my X. This is my normal distribution, my distribution of pumpkins, and then I do my standardized, or my Z distribution, and I color it in exactly the same. And then I'm going to use this to put my Z value when I find it, because right now my X value is here and it's 5 kg, right? And what we're doing is on our Z table, we're going to try and find our Z value, and it sort of reminds me to go and find that Z value. So let's do that now. So we remember that Z, to get from this one to this one, Z equals X minus the mean over the standard deviation. So see how it sort of like links them up in your mind. So you've got your Z, you've got your X, and it shows you why you're using the formula. I like to come into these things with understanding so that when you get to like harder questions, you will have such a good understanding of them that you'll be able to problem solve them on the spot. Okay, so our little Z value is going to come out to being, we get little x, 5, minus the mean, 4.1, over the standard deviation, 0.45. Okay, let's see if we can do that in our heads. That's 0.9 over 0.45, which is conveniently half of 0.9, so that comes out at 2, or 2 over 1. You could do that on a calculator, and we'll do that in future problems, but it's just really nice. So our little Z value is 2. So I can label that on my distribution here, and that's going to make it easier when we go to the next step. So yeah, they draw the picture, they've already done it for you, calculate the Z value, that's what we were doing. We've just done an extra step of drawing an extra picture. So we've sort of added on like a step 1.5, draw proportional Z. Right? We're just drawing a Z that looks the same so we can get an understanding. The reason we do that is because this area here is going to be exactly the same as this area here. Right? And it's just going to round off our understanding of it. Okay, so I'm going to now open the formula sheet. You can find this, how did I do it? I just typed in NCA formula sheet level 3 stats. This is the one that you get during the exam, so it's good to practice using this one. But remember, it's also in the back of your book. So you can also go into the back of your Walkermaths book. Where is it? And it's just here. It's exactly the same thing. Maybe a little bit prettier. Nah, not really. Anyway, okay, let's go back to this. So our Z value is straight up 2. Now, I'm just going to make this a little clearer. It's actually 2.000, right? We can find, using the tables, we can find anything to 3dp. It's just that this one conveniently is exactly 2. So that 2 is the same as 2.000, and I'll show you why we did that. So now we go to our tables, we go to Z, and we go down to 2.0. So the reason I put this is the 2.0 is this aspect, right? And then the extra DPs is normally, so you normally highlight this, oopsies, normally highlight this, and then you look over to 2.00, so it would be 0.4772. So the probability that pumpkins are between 4.1 and 5 is equal to 0.4772, right? Because you'd normally go across and you go, well, 2.0 and then a difference of 0. Oh, okay, sweet. So that's our probability right there. Now, something I kind of want to point out is, why am I doing this crazy notation, right? And what is this? This is saying the probability that pumpkins are between 4.1, so 4.1 kg pumpkins are less than our pumpkins, and 5 kg pumpkins are greater than our pumpkins. That's the reason I write it like this. And I want to write it like this is because when we were looking at our Z1, we were looking between 0 and 2, right? So that would be the probability that Z is between 0 and 2. And this is actually what we were looking at when we were on our normal distribution. See how, or our standard normal distribution, we were looking here between 0 and our Z value. Now I'm doing this to build up your understanding, and this probability is proportional, right? And that's the whole reason we do this like Z transformation thing. These probabilities are exactly the same as each other, 0.4772 and 0.4772. Right? So this is the answer to your question. If you put this in your, to be honest, in NCEA, if you just write 0.4772, you get an achieved mark. So yeah, it's definitely worth knowing. So yeah, the probability that a pumpkin weighs between 4.1 kg and 5 kg is 0.4772. Okay, how much time have I taken from you so far? Okay. What we're going to do is we'll go straight to the next question, because now we're going to start having to like build up our understanding a little bit. This is when things start to get probably a little bit more interesting. The difference here is this one's looking, it's not like the standard, the very, like, what the table does for us is whenever it's between 0 and some Z value, right? That's what the table does for us. But this one's different because now our Z value is going to be here, and not only are we taking from the mean over to the Z value, we're also going to add on this whole region to the left, right? So there's just going to be like a little bit extra that we're adding on, but it should be pretty straightforward. Okay, pumpkins from a large crop are found to have a mean weight of 4.1 kg. Boom, first thing I do, mean equals 4.1 with a standard deviation of 0.45. Dang it, this is exactly the same question. Calculate the probability the pumpkin weighs less than 5 kg. So instead of, before we were looking at P 4.1 less than X less than 5, we're now just looking at this. P X being less than 5. That's all we're looking at now. It seems simpler, but it's just going to be like one extra step of working. Okay, so remember before we worked out that 5 kg was here, right? We then drew our proportional Z. Oh, it's looking a little prettier. It's still not that pretty, right? And we worked it out before we found our Z. Let's do it real fast because we already did it before. X equals Z minus mu. Oopsies, that's actually totally wrong. My bad. We worked out that little z was x minus mu over the standard deviation. So we worked out that that was 2 before, right? So we found that Z equals 2. Now, the difference is, before we just looked at from 0 to 2, and we found that probability, right, was 0.4772. Now, here's the difference. We are also adding on this whole section here. So even when I'm drawing my Z, I'm going to shade in this as well. Because on our X, it says weigh less than 5 kg. So that means everything under 5 is going to get shaded in. So we're trying to find this whole probability. Everything under 5. And it's really convenient that our normal distribution, let's just look at a fact again. Where should I draw these pictures? I'm going to draw them up here. Remember, we worked out with normal distribution, there's some facts about it. We follow M, A, S, S. And M means that the mean, it's mainly around the mean and the mode and the median are all the same thing. A means it's asymptotic. It means that these things go on forever. These ones we don't really care about too much for what I'm about to explain. The things that I think are important for now is that it is symmetrical. This one is the important one. Actually, shaped like a bell doesn't matter too much. The fact that it's symmetrical is what's important here. It means that either side is going to be equal to each other. And as we know, probabilities all add to 1. So the total area is 1. Total area is equal to 1. So if it's symmetrical, we can then deduce or say that half of the area is going to be 0.5, because half of 1 is 0.5. So we now know that in our normal distribution, each half, so everything less than the mean is 0.5, and everything greater than the mean is equal to 0.5. This area that is here, everything under the mean, the area is going to be 0.5 in total. Everything over the mean is going to be 0.5 in total. And we're going to use that fact right now, because on our standardized Z, we now know that this is 0.5. And if we know that that's 0.5 and that's 0.4772, we can now work out this probability here. So the probability that X is less than 5 is just going to be proportional to this, 0.5 plus 0.4, oopsies, how am I going to make that a 4? 772, which is 0.9772. And that is the probability that a pumpkin weighs less than 5 kg. Let's push on. We may as well do this all in one video. Okay, pumpkins from a large crop are found to have a mean weight of 4.1 kg. Man, why are they giving us the same question over and over again? It's probably smart. It means we're focusing more on the concepts. Mean equals 4.1 again. Standard deviation, let me guess, 0.45. Calculate the probability that a pumpkin weighs more than 4.7 kg. Let's write that out first. Probability that pumpkins, which are modeled by X, is more than 4.7 kg. So X, the pumpkins, are going to be greater than 4.7. Remember, the best way to do this, the crocodile eats the bigger thing. Normally we say the bigger number, but in this case it's a random variable, not a number. Right? Pumpkins that are larger than 4.7 kg. That's how we're going to write it. Okay. What's the picture going to look like? Where's 4.7? Well, 4.1's here. 4.7, it's about 1.5 standard deviation, is it? I don't know. 4.7 kg. And if we're looking at weighs more than 4.7 kg, so we're looking at all of the pumpkins on this side, everything that is larger. This is the probability that we're looking for right here. Ooh, shucks, do we know how to do that? Okay, what we're going to do is we're going to do a proportional Z, and I'm going to show you the power of drawing these and how it can be really good for if you're a visual learner, or, I mean, humans are actually very visual creatures. Look at us using our eyes to watch this video. Come on. Okay, this is X, this is pumpkins, This is our proportional z. We can transform them. Now, what we're going to transform is this 4.7. Let's do it. Z equals x minus mu. By the way, you don't need to write all this stuff out when you're doing your exam. I just do it for your sake, I think. 4.7 minus the mean, 4.1, over standard deviation, 0.45. Is it a nice number? 0.6? Yes, it is actually. 0.6 over 0.45. Why is that such a nice number? Because 0.6 is related to 0.45 in the sense that 60 is 4/3 of 0.45. Beautiful. Is that right? Does that mean 1.333? 4/3? Doubting myself. No, yeah, that's right. And that goes on for eternity, but we can only do 3dp on our table. So we've got our little z value, right? So what we're going to do is, watch this. This is going to blow your minds, right? We've got 0 here. We've got 1.333 here. Let's go to our table. Now our table only shows us between 0 and z. But you know what? We've got a question like that. Look at that. 0 and z. Perfect. We can find this area. All good. So let's find this area. 1.3 recurring. Man, the more I think about it, the more I doubt if what I did was correct. Dang it, I just want to confirm for you guys. Okay, 0.6 over 0.45. When you're recording a video, you doubt yourself, because if you make a mistake, you pretty much delete the whole thing. Sweet. And so you've just got to be super careful, and that's what I'm doing. Okay, you should also do the same in your exam. If you're sitting your exam and you're calculating stuff, don't bother using your head. Unless it's really straightforward. If you use your head, you're way more prone to making mistakes. So just have your calculator open at all times. Have this here. Unlike what I was doing. Don't do it in your head. Don't make my mistakes. Okay. 1.3 recurring. Boom, we found it. 1.3. Let's go to our table. So we go to 1.3. We highlight that row. If you've got a ruler in the exam, that's a good thing to do. And we go down to 3. So it's this one, 0.4082. 0.4082. But watch out, because we've got this difference thing here. So I'm just going to put my little plus here now so I don't forget to add it on. Okay, so we've got a 3. So we're going to have to add on 0.0005, will it? Yeah, 5. Okay. So that means that probability, I'm going to draw a real ugly thing here, 0.4087. But remember, do it in your flipping calculator, don't do it in your head. Maybe you should do it in your head, I don't know. Okay, we found this area, 0.4087. Now, we are actually trying to find this area in the original question. So luckily we can work with our Z standardized and just mess around with it for a bit. So if we know this area here, between 0 and 1.3333, we want to find everything beyond. We want to find what's here in pencil. So we're going to have to use some logic to do that. And I guess if you're at home, you may have already thought of how to do it, but otherwise maybe not. Right? Pause the video now if you want to try and think about how you might find this. But moving on. The thing is, we're going to use this exact same logic, right? We know that half of the normal distribution is 0.5, and the same goes for this half. We know that this is 0.5. Now, if this is 0.5, and we've found a portion of that area, we found this area, we know that this area plus this area is going to equal 0.5. So, say I labeled this as being A, and I labeled this as being B, we can say that A plus B is going to be 0.5. And with the same logic, we could then say that 0.5 minus A would get us to b. Right? How do I show that algebraically? Pretty much you minus a off both sides, and so the a goes over to here and flips signs, so it goes 0.5 minus a is equal to b. So this is the logic. This is why. Right? Because on our distribution, this is 0.5 in total. So that means that 0.5 minus a section of it is going to get us to what's left over. So then we can use that to find b. So this bit's going to be 0.45 minus 0.4087. And that's going to get us to, don't do this in your head, people, 0.0813. Oh man, do not risk doing that in your head. Use your calculator, come on. You may as well, it means you don't have to flip and think. 0.5 minus 0.4087. That's why you use your calculator. Look at that. You make mistakes, people. You make mistakes. Okay. 0.0913. Okay, that is that area. Now that we know that, and we know that this is proportional, we can therefore just nicely write 0.0913. Voila! That's why I like to have both of these things, so I can play around with them for a bit. So now we have our answer. The probability that x is greater than 4.7 is 0.0913. Sweet. Do we push on? No, I'm going to make another video.